This is what we will try to recreate in this video. What you are seeing is the map of the city of Vancouver. The polygons of the local area boundaries are shaded relative to the population. The trees represent parks in the local communities, and the blue dots are heritage buildings. In this tutorial, we will use Tableau's multiple mark layer support, as well as other techniques like join, relationship, level of detail expressions, and custom shapes. I will also use a simple but powerful Power Query technique in Excel to clean up one of the datasets. I'll see you in a bit. I want to walk you through the datasets first. All of these datasets are coming from the City of Vancouver Open Data Portal. So if you want to follow along this tutorial, you should be able to download all of the datasets you need. Where I need any kind of map, I have downloaded the GeoJSON file. You should be able to use the shapefile or the KML file as well. The first dataset is a parks dataset. In here, there is a geometry field that represents a park in a neighborhood. In this exercise, we're also going to replace each dot with a tree icon, with a tree map symbol to represent these parks. The second dataset is about the heritage sites in Vancouver. There's also a geometry field here that represents a heritage building or structure. One more dataset that we'll use is the local area boundary. Notice that the geometry field in here shows a polygon or a shaded closed area instead of dots or symbols. The final dataset is all about the local area population. All I really want in here is this first line. So this is the total population for each local area. But this dataset also has so many other columns and rows that we don't need, so we will take those out. We are going to clean this up using Excel Power Query. All we want is the local area and the population. And we are going to overlay this population in the polygons, so it gives us a shaded area that shows us relative population density across the whole city. Now let's walk through how these are all connected. The local area boundary has a field called name, which represents the neighborhood name. And I've called it local area in our Excel file. And this is connected to the neighborhood name in the park's GeoJSON file. And lastly, it's called local area in the heritage GeoJSON file. Now that we know the datasets and how they're all connected, we're ready for the walkthrough. I've downloaded all the datasets. Let's start by cleaning up the Census local area profile in 2016. There are different ways to clean up this dataset. I'll choose one way so that we can showcase other ways you can clean up data using Power Query in Excel. The data that we need is really just the local area population. I'm going to select rows 5 and 6, and under the data menu, we can select this option called From Table/Range. In here, we're just going to confirm that we're going to create a table, and it's from this range that we have selected. What this does is it opens up the Power Query editor. Power Query is a data preparation engine, and you can see this within Excel or Power BI. You can think of it as a way to do ETL within Excel or within your desktop. ETL stands for Extract, Transform, and Load, and this allows us to collect data and clean it up before analysis or visualization. In this case, we are going to leave only the columns that have population information for the local area. And it's actually from Arbutus Ridge, so I'm going to select that, all the way to West Point Grey. These are the only fields that we really need. So once we've selected, we can right-click and we can remove other columns. What you're also going to see in here is all of the actions that we do, they're going to be logged under the Query Settings pane. So if you make a mistake or you need to rearrange some of these steps, you can simply just rearrange it from here or remove that step altogether. Once we've removed all of the other columns, let's select all of these other columns that are left, and let's go to the Transform menu. And in this ribbon, we're just simply going to select Unpivot Columns. Unpivot means we're going to take all of these columns and we're going to transform them into rows. And from here, we're just going to rename all of these fields. So instead of attribute, I'm going to call this local area. Instead of value, I'm just going to call this population. Once we're happy with our changes, we can go to File, and we're going to close and load this into a new worksheet. So from here, we're just going to select OK, and we're just going to rename this tab. So let's call this Local Area Population, and save it. And let's close it. So now that we've prepared our data set, we can create our visual. I'm going to start by dragging over the local area boundary GeoJSON file into Tableau. One thing to notice is GeoJSON is a file. So technically in Tableau, we have connected to a file. You're going to see all of the other files inside that folder as data sources already. So you don't need to drag over all of these other files in here because they are already accessible. Now, what I also want to do is within the local area boundary, I simply want to append population in here so that it's easier for us to map all of the boundaries with their respective population. So what we see in Tableau, this first box in here is what we call a logical layer. You can think of it as a layer of abstraction. It looks like we have a single table, but in reality, there may be multiple physical tables that are composing what we're seeing on screen. If our goal is to add one more column in here that has population, but it's really coming from a different table altogether, what we can do is we can go to the physical layer, do our joins, and surface the columns that we need. Now, when you hover over these boxes, you're also going to see indications that this is a logical layer, and it also tells us double-click this logical table to see its physical table. So once we double-click, we are going to see another box, and this is what we call the physical layer. The physical layer is where we do operations just like join and union to get all the rows and the columns that we need. So as far as the logical layer is concerned, it's going to treat this as just one table, but in reality, there's multiple tables that are contributing to all the columns that you're seeing in the surface. So to add our population column, we need to add our census file. We can do this two ways. We can either simply drag this over or also click on the add and navigate to the folder that has that file. So I'm simply going to choose to drag this over. And I know this is the new tab that we created. And if we want to verify, we can simply hover over and click on the view data icon to verify all the records in this particular tab. And we can simply drag this over. And this is where we can choose the type of join. Tableau supports inner join, left join, right join, full outer join for Excel files, but note that for other data sources, not all types of joins may be supported. Now we're also getting an error because the field names are different, so we just need to make sure we map it. So in here, we're looking at name, and under local area population, we've called it local area. I'm going to choose a left join because I want the local area boundary records to be preserved, whether or not there is corresponding population records for it. Now in here, we're also going to notice that local area and name, they both have the same values. So I'm simply going to hide one of these fields. So I'm going to choose local area and I'm going to hide this. Now we're done with the local area boundary, so I can close this physical layer. And now, as far as Tableau is concerned, whenever I select this logical layer, it will show me all of the fields that are from our local area GeoJSON file and also the population from the local area population Excel file. Now let's switch back to local area boundary. Now it's going to be easy to make the relationships now between logical layers because we have all the fields that we need now. So when I drag over the parks GeoJSON file, you're going to notice this flexible line that's moving around, and this is called the noodle. The noodle allows us to create relationships for related data sources in Tableau. If you want to learn more about the relationships feature in Tableau, I do have a separate tutorial that differentiates blend, joins, and relationships. I will link it up in the card above or the description down below. Now it's going to ask us what is the relationship between these two different tables. So we just need to supply all the field names that relate these two. But in the parks file, it's actually called neighborhood name. One of the differences between joins and relationships is that when you select that logical layer, it will only show you all the fields that are coming from that data source. So notice in here, these are all the fields that are coming from the parks file, but you are not seeing any field from the local area boundary. Whereas if you have joins, so if we double click on the local area boundary again, whereas in joins, the view that you see in the preview is always going to be the combination of the joined tables. It doesn't maintain the identity of the individual tables. The last file that we need is the heritage sites. So let's add heritage sites. This is going to be a noodle as well. It means it's going to create a relationship between local area boundary and heritage. We are getting an error because the field names don't match, so we just need to manually override this. So name corresponds to local area. And once we have this relationship, we can create our sheet now. By the way, this is pretty real life. This is pretty realistic that we spend a lot of time and sometimes more time collecting, preparing, transforming, and cleaning up our data before we can do our analysis. So let's start with the local area boundary. Inside the local area boundary, we already have a field that is a geolocation. So you can see it with the globe icon, with the globe data type. To create our first map layer, we can simply just double click on this geometry field. So these are all the boundaries. Let's also drag population to color. So drag population right here, go to color. Now something seems off here. How come there's only one big color among all the local area boundaries? If we take a look at the marks card, we're actually going to see that geometry is inside another function called collect. And collect is an aggregation function. So right now, this is very similar to sum, where we're saying this is the total of something. But what we really want is we want to subdivide this by local area. So for us to see different colors per local area, we need to make sure that the local area field is inside our detail or somewhere in our marks card. So notice that once we drag the name to detail, we're going to see differences in color. I'm just going to change the color palette. So double click on the color legend. Just going to change this to a warm gray or gray warm. Click OK. We're going to adjust this later on, but for now, this is good enough. Now, starting version 2020.4, Tableau has introduced support for multiple marks layers for maps. So now we already have a single map layer. If we wanted to add another one, we can simply find another geometry data type and drag it over. So now if we drag over geometry from our parks table, we can see that there's going to be a new option for us where we can drag over that new marks layer. So let's drag this over. Now what this gives us is still a single marks card. But within the marks card, we have two layers. The first one is for the parks, and the second one is for our local area boundary. Now it's important that as we use this feature more and more, that we label them properly, because otherwise it might get really confusing which layer stands for what. So let me just rename this first. So right now in here, I'm going to rename the local area boundary to local area boundary. And I'm going to rename the parks to just parks. Notice in here as well that each layer is basically its own marks card. It has independent properties. It has its own mark type, its own color, size, label, detail, tooltip, and also the sixth property that will show up depending on the type of mark that you choose. If we hover over a map layer and click on the top right corner where we see an arrow, these are the options that we see. We can choose to disable selection for that particular map. Zoom extent is when we have different map layers that have different levels of detail. So for example, you have one layer that is at the country level, and you have another layer that is just at the state level or the city level. When we check this, it allows us to show all the details for that particular map layer. If we uncheck it, we're actually allowing Tableau to zoom in to a lower level and not necessarily show all the details for that map layer. We can also choose to move our layers up or down, but we can also do this by dragging. We can rename, we can hide, and we can also just remove. We can also choose to hide the map layers. So as we hover over a map layer, we can see that the icon becomes an eye, so we can make this layer invisible. For example, if we choose this, then we're not going to see the polygons at all. So let's finish setting this up. Let's go back to parks. And in here, let's actually just drag over park ID, make that into a dimension, and also put that in the detail. So park ID is not a measure, it is a dimension, and we're going to drag it over to detail so that when we hover over each one of these symbols, it's actually an individual park. Now I want to use a custom shape. Instead of the dots, I want this to be represented by tree icons. So in the Tableau repository, under the Shapes folder, I have created a brand new folder called Trees, and I've put my new icon in there. This makes this icon accessible to me when I choose the Shapes palette. So let's do that right now. So in here, selecting Parks, we're going to change this to Shape. So let's click on Shape and More Shapes. If you've added a Trees folder and the icon when Tableau was open, you are going to need to reload shapes. Otherwise, the new palette should just simply show up in your dropdown. So on the dropdown, there's the Trees folder, and I can simply change the circle with a tree. We can adjust the size. Now I want to change the color of the trees as well, but if I simply click on the color palette and choose green, it actually doesn't change. So I will create a calculated field that has a single value. So on the dropdown, create calculated field. I'm just going to call this tree, and with just a constant value of tree, because I want to be able to just drag this over to color. So click OK, and we can drag this tree over to color and change this color now to green. So we can use a green palette and choose a dark green. We're going to need to make adjustments with color later on so that it's not too overwhelming. But for now, this is good. So now let's add the heritage sites. Let's expand that. Heritage sites also has a geometry field, so we can simply drag this over, or your other option is to right click on that geometry field, and you can also select add to new layer. So depending on what your preference is, my preference will be to drag it over. Now we can see that it's actually quite overwhelming. And notice as well that as we hover over, all of the dots are selected. And remember, this is because by default, all of these fields are aggregated using the collect function. If we want to disaggregate it somehow, we're going to need to drag over a field that allows us to separate each one of these. For the heritage sites, it's actually ID. So we can simply drag that over to detail, and we can see now that it allows us to select only single circles at a time. Let's change this layer name. Let's call this heritage sites. Let's also change the mark type to circle. Let's also adjust the size, drop it down a little bit, change the color, maybe make it blue. And let's also drop down the opacity level, so it's not too overwhelming, but you can still see where the density is. And let's move the parks mark layer on top of the heritage sites so we can see the trees more prominently than the blue dots. We are almost to the final stretch, but there's a couple of things we need to adjust. If we add a filter for the local area boundary name, so in this case, I'm going to right click and show the filter. I'm just going to make this into a slider just for demonstration. So on the drop down, single value slider, let me just quickly disable selection for both parks and heritage sites. Actually, maybe let's make those invisible for now. So make parks invisible and make heritage sites invisible. So what we're basically seeing right now is if we have all of the local area boundaries visible, we can see the difference in color in terms of population. However, notice what happens when I go through each local boundary. The color actually now stays the same because there is no comparison. It cannot compare it against all of the other ones that are not visible. So one way we can adjust this is to color each polygon based on the relative proportion or the percentage of the population. And this is where we can use level of detail expressions. So let's create a calculated field. And let's just call this percentage of population. And this is simply going to be the sum of population divided by the fixed grand total, the fixed sum of population. And we can use a fixed tablescope level of detail expression here. If you need a refresher on the level of detail expressions, I do have another tutorial for that. I will link it up in the card above and the description down below. So we're simply going to put curly braces. This is going to be the sum of population. Now we are getting an error because the table scoped LOD expression returns a scalar value, and we cannot mix aggregate and non-aggregate arguments. So the numerator is aggregated, but the denominator is a scalar value. It's non-aggregated. So all we really need to do in here is to enclose this in another aggregated function. I explained this nuance too in the other tutorials. So in here, let's just type in sum. And let's also just change the default property so that this shows percentage. So under number format, going to be percentage, 2 decimal places. We can leave it as is. So the final thing we need to do for this step is in the local area boundary, we still need population. So we're simply going to toggle this color into detail, and we are going to drop our percent of population to color. Let's change the color palette again. Let's double click on the color legend, change the palette back to gray warm. So let's just click on apply. And to ensure that we are keeping the color for that particular polygon, we can go to advanced and we can actually fix the end so that the colors are always relative to the maximum number. There are other ways we can do this. We can use calculations, but for now, this serves our purpose. So let's click on apply and click OK. So let's test this out. As we go through the different local areas, let's see if the shades will actually vary. Arbutus Ridge, downtown, so we can see that the shades are actually a little bit different for each local area, so that's good. So this is it for the multiple map layers walkthrough. The final touches are going to be on the aesthetic part, making some final adjustments on the map, changing the map layers, changing the color, the opacity, adjusting the title, and formatting the tooltips. And while this is a simple walkthrough, I hope you found value in us using real-world datasets and actually using many different features in Tableau that tie everything together into one potentially real-world use case. Thank you so much for watching. If you haven't subscribed yet, please consider subscribing. And I'll see you again next time.